They were convinced that their tanks were invincible. The Type 95 Hago had proven itself against Chinese forces, against Soviet armor at Khalkhin Gol, and in the overwhelming victories throughout Malaya and the Philippines. Japanese tank crews believed their light tanks represented the pinnacle of armored warfare design, perfectly suited for the jungles and islands of the Pacific. They had crushed every enemy they encountered. They were wrong. The story of how they discovered this begins not with defeat, but with the confidence born of years of success. The Hago was not a design accident. It was the product of careful military planning that began in 1933, when the Imperial Japanese Army recognized a critical gap in its armored forces. The Type 89 medium tank, Japan's workhorse, could reach only 15 miles per hour. This was adequate for supporting infantry at a walking pace, but entirely inadequate for the mechanized warfare the Army envisioned. Japanese military planners watched with interest as other nations developed faster and more mobile armored forces. They wanted a tank that could keep up with motorized infantry moving at 40 miles per hour by truck, that could navigate the terrain of Manchuria and China, and that could be produced in quantities their industrial base could sustain. The Army Technical Department issued specifications in July 1933. The new tank would weigh approximately 7 tons, mount a 37mm cannon, reach speeds of 40 kilometers per hour, and have enough armor to resist rifle and machine gun fire. Most importantly, it would be simple to manufacture and maintain. Mitsubishi Heavy Industries received the contract. Engineer Tomio Hara, who had already made a name for himself designing the Type 89, accepted the challenge. His most notable innovation was the bell crank suspension system, a simple but effective design that would become standard on Japanese tanks for the next decade. By June 1934, Mitsubishi had completed the first prototype. The prototype impressed military observers during field tests conducted in Manchuria and on proving grounds in Japan. It was fast, reaching 45 kilometers per hour on paved roads and maintaining 25 to 30 kilometers per hour off-road. It was maneuverable, with a turning radius that seemed impossible for a tracked vehicle of its size. Hara's suspension, with its distinct bell crank design, absorbed shocks well and allowed the tank to traverse rugged terrain that would have stopped other vehicles. And it was mechanically reliable, using a 6-cylinder air-cooled Mitsubishi diesel engine that produced 120 horsepower at 1,800 revolutions per minute. The diesel engine was a point of particular pride for Japanese engineers, making the tank less vulnerable to fire than gasoline-powered vehicles. Diesel fuel was also more readily available in the Japanese Empire, particularly in areas like Manchuria and Southeast Asia, where gasoline supplies were limited. The engine could run for 8 to 10 hours with its internal fuel capacity of 34 gallons, giving the tank an operational range of approximately 130 miles on roads. Testing revealed some problems. The suspension had a tendency to pitch violently on uneven ground, making aiming on the move nearly impossible and causing crew fatigue. Engineers solved this by adding braces to connect the pairs of bogies, creating what became known as the Manchurian suspension. The modification helped, but did not completely eliminate the rough ride that would characterize the Hago throughout its service life. In 1935, at a meeting at the Army Technical Department, the Type 95 was formally presented as the potential primary tank for mechanized infantry units. Infantry representatives had concerns. They argued that 12 millimeters of armor was insufficient for a tank that would support infantry attacks against fortified positions. Cavalry representatives countered that the improved speed and mobility compensated for the thin armor, and that the tank's firepower was adequate for its intended role. After considerable debate, the infantry agreed to accept the design. The Type 95 Hago was officially adopted. The designation came from the Japanese imperial calendar, marking the 2595th year since the legendary founding of Japan. Only the last two digits were used in the type number. Production began at Mitsubishi facilities in 1936. The Hago was, in fact, a small tank. It measured only 4.38 meters in length, 2.06 meters in width, and 2.13 meters in height. A man of average height could look over the turret. The weight stood at 7.4 tons for the basic tank, reaching 8.1 tons when loaded with crew, fuel, and ammunition. The armor was thin by any standard. 12 millimeters at its thickest points on the turret and upper hull, 9 millimeters on the roof and floor, 6 millimeters in some less critical areas. Japanese designers had calculated that this was enough to stop rifle and machine gun bullets at combat distances. They were designing for the enemies they expected to fight: Chinese forces with limited anti-tank capability and Soviet light tanks. Inside the tank, space was tight. The crew consisted of 3 men. The driver sat in the front left of the hull, with limited vision through a small slit and periscope. A hull machine gunner sat to the driver's right, operating a 7.7 millimeter Type 97 machine gun, mounted in a ball mount. The commander occupied the turret alone, standing on the hull floor, with no turret basket beneath his feet. This commander had perhaps the hardest job in the Imperial Japanese Army. He had to command the tank, directing the driver and communicating with other tanks when radio was available. Only 1 tank in 4 possessed a radio, leaving the others to follow visual signals. He had to operate the main weapon, a 37 millimeter Type 94 cannon capable of firing both high-explosive shells and armor-piercing projectiles. He had to load this weapon, a physical task made difficult by the cramped space and the need to stand while doing so. And he had to operate a second machine gun mounted in the rear of the turret, facing toward the rear right, at approximately the 5 o'clock position. American tankers, who later examined captured Hagos, marveled that anyone could function effectively under such conditions. The Japanese commander had no seat in the turret. He remained standing throughout combat, with his head and shoulders exposed if he opened the hatch for better vision, or confined to a small space with minimal visibility if he closed it. The turret rotated by manual crank, requiring significant physical effort. There was barely room to move, let alone to fight efficiently. But in its intended role against the opponents for whom it was designed, the Hago performed well, very well indeed. The tank saw significant action first in China, starting in 1937, against Chinese forces that had practically no armor and possessed limited anti-tank weapons. The Hago was devastating. Its Taitoidiwa 37mm cannon could destroy fortifications and suppress infantry. Its machine guns mowed down troops in open fields. Its mobility allowed it to exploit gaps and pursue retreating forces. Japanese tank crews gained combat experience and confidence. They learned their craft in an environment where their tanks were clearly superior to anything they faced. This success spawned the dangerous assumption that the Hago was a genuinely capable tank, rather than a vehicle optimized for a specific and limited scenario. This assumption was tested at Khalkhin Gol in 1939, where Japanese forces clashed with the Soviet Union along the Mongolian border. Here, the Hago faced real opposition. Soviet BT-5 and BT-7 tanks mounted 45mm cannons with better armor penetration than the Japanese 37mm. Soviet armor was thicker, making frontal combat difficult for the Hago. The battles were brutal. On July 2, 1939, the Japanese 3rd Tank Regiment, equipped primarily with Type 95 tanks, attacked Soviet positions. The initial assault achieved some success through aggressive tactics and surprise. Japanese tanks destroyed 32 Soviet tanks and captured 35 armored vehicles. But Soviet counterattacks in the following days revealed the Hago's vulnerabilities. Soviet weapons could penetrate the Hago's armor at distances where Japanese weapons struggled to damage Soviet tanks. By the end of the Khalkhin Gol campaign, Japan had lost dozens of tanks. The lessons were clear to anyone paying attention. The Hago was outclassed by modern Soviet armor. Its thin protection and relatively weak cannon were not suited for tank-versus-tank combat against peer adversaries. But these lessons were not fully absorbed. Japanese military leadership focused instead on tactical improvements and crew training, rather than a fundamental redesign of their armored forces. The war in China continued, and there the Hago remained effective. When war broke out across the Pacific in December 1941, Japanese tank units achieved notable successes in Malaya. Hago tanks navigated terrain that British commanders judged impossible for armor. They moved through rubber plantations and jungle trails, supporting the rapid Japanese advance down the peninsula toward Singapore. British forces, which had not deployed significant armor to Malaya, were unprepared for this mobile threat. In the Philippines, Hagos landed with the invasion force and supported Japanese infantry operations. On December 22, 1941, north of Demortis, Type 95 tanks engaged American M3 Stuart light tanks in what would be recorded as the first tank-versus-tank battle involving U.S. forces in the Pacific. Both tanks mounted 37mm cannons. The M3 had better armor, 32mm on the turret sides compared to the Hago's 12mm. But at close range in jungle fighting, the Japanese achieved some success, destroying one M3 in the initial engagement. These early victories reinforced Japanese confidence. From their perspective, the Hago was performing exactly as designed. It was mobile, reliable, and effective in supporting infantry operations across diverse terrains. Tank crews trusted their machines. Commanders relied on their armor. And when the orders came to defend Saipan, the Japanese brought their tanks without questioning their suitability. Saipan was different from the battles that came before. The island in the Marianas chain was strategically vital, positioned just 250 miles from Tokyo. If the Americans captured Saipan, their B-29 bombers would be within range of the Japanese home islands. The leaders of the empire knew this. They fortified Saipan with approximately 30,000 troops, nearly double what American intelligence estimated. Among the defenders was the 9th Tank Regiment, commanded by Colonel Takashi Goto. The regiment was equipped with 44 tanks, a mix of Type 95 Hago light tanks and slightly larger Type 97 Chiha medium tanks. The Chihas were better armed with 57mm cannons, but shared the thin armor that characterized Japanese tank design. These tanks represented a significant armored force by Pacific standards, certainly the largest the Americans had ever faced. The Americans began their assault on June 15, 1944. Vice Admiral Richmond Kelly Turner ordered the landing force at 05:42. By 07:00, landing barges were moving toward the beaches. At 08:40, the first wave hit the shore. The 2nd and 4th Marine Divisions landed on the western beaches of Saipan under heavy fire from Japanese artillery and mortars positioned on the heights overlooking the landing zones. The Marines struggled to advance inland against fierce resistance. By nightfall on the 15th, 20,000 American combat troops were ashore. Equipment and supplies were pouring onto the beaches. Among the equipment were M4 Sherman medium tanks, landing from LST vessels and moving forward to support the infantry. The Marines established a beachhead, but it was not yet secure. Japanese artillery could still hit the beaches. Counterattacks continued throughout the night. On June 16th, the Marines consolidated their positions and began to push inland. The 2nd Marine Division worked to close gaps in the line. while the 4th Division cleared areas around key terrain. General Holland Smith, commanding the assault force, committed his reserves, bringing in elements of the 27th Infantry Division to reinforce the beachhead. Lieutenant General Yoshitsugu Saito, commanding Japanese forces, on Saipan, recognized the critical situation. If the Americans consolidated their beachhead and brought their full combat power ashore, dislodging them would become impossible. He needed to strike before they were fully prepared. Saito issued orders for a massive counterattack using the island's most powerful assets, the infantry of the 136th Regiment and the tanks of the 9th Tank Regiment. The order of attack was specific. The infantry would attack American positions around the Garapan airfield. The tank unit would advance southwest from Hill 164.6, moving after the start of the infantry attack. The tanks would attack the transmitter station and throw the enemy into disorder before the infantry penetrated the sector. It was an ambitious plan that required coordination between infantry and armor in a night attack through difficult terrain. Colonel Goto gathered his tank crews. They performed final maintenance checks on their vehicles. The crews loaded ammunition, 37mm, shells for the Hagos, 57mm for the Chihas. They filled the tanks with fuel, checked track tension, and tested radios in the few tanks that had them. The crews were confident. Many had combat experience in China or in previous Pacific campaigns. They trusted their machines and their tactics. In the pre-dawn darkness of June 17th, the Japanese tank column set out. Diesel engines roared to life, their distinct sound echoing across the pre-dawn landscape. Tracks clattered as the tanks formed up and began their approach toward the American lines. Inside each cramped vehicle, the crews felt the familiar vibration and noise of their tanks in motion. Commanders stood in their turrets, trying to peer through the darkness, coordinating movement through visual signals. The Americans heard them coming. Marine sentries on the perimeter reported engine sounds from the north. Officers shouted orders. Men grabbed weapons and moved into defensive positions. Anti-tank gun crews turned, their 37mm M3 guns toward the approaching sounds. Sherman tank crews who had bivouacked near their vehicles climbed aboard and started their engines. Machine gun teams checked their weapons and ammunition. At 03:30, the Japanese attack began in earnest. 44 tanks, the largest armored formation ever employed by Japan in the Pacific, advanced toward the positions of the 2nd Marine Division. Some tanks carried infantry clinging to the hulls, a dangerous but sometimes effective tactic. The Reserves formation moved through the darkness, guided by the lead tanks and following the terrain toward their objectives. The Marines saw them first as dark shapes emerging from the pre-dawn gloom. Then came the characteristic sound of diesel engines at full throttle, tracks throwing up dirt and dust, the clatter of road wheels, and the screech of steel on steel. The Japanese tankers could see the Marines in their positions. They could see the defensive line ahead. Some commanders opened fire with their hull machine guns sweeping the ground ahead. Others held their fire, trying to get closer before engaging. Then something unexpected happened, something that would fundamentally change the way Marines viewed Japanese armor for the rest of the war. Marine machine gunners positioned in foxholes and behind cover opened fire with their Browning M2 heavy machine guns. These were not the standard infantry machine guns, the .30 caliber weapons that provided supporting fire. They were .50 caliber weapons, heavy machine guns designed to engage aircraft and destroy light vehicles. The .50 caliber Browning M2 was a formidable weapon designed near the end of World War I and perfected in the following decades. It fired a 12.7mm projectile at a muzzle velocity exceeding 2,900 feet per second. The standard ammunition load included common projectiles for general use and armor-piercing projectiles specifically designed to defeat light armor and fortifications. The armor-piercing variant could penetrate 23 millimeters of hardened steel armor plate at 200 meters. At 500 meters, it could still penetrate 19 millimeters. These were not theoretical numbers. They were verified test results, confirmed through extensive firing trials at American Ordnance Proving Grounds. The ammunition had been designed to engage aircraft and lightly armored vehicles, not to defeat tanks. But the math of armor penetration is relentless. The Type 95 Hago's armor was 12 millimeters thick at its maximum onto the turret front and sides. On the upper hull, the thickest armor in the entire vehicle was 12 millimeters. Simple arithmetic revealed the problem. The 50 caliber armor-piercing projectile could penetrate nearly double that thickness at close range. At the distances the battle was being fought, 200 meters or less, as the tanks approached the Marine positions, the 50 caliber had more than enough penetration power. The Marine machine gunners opened fire. Tracer rounds streaked across the battlefield in bright orange-red lines. The sound was distinct. The heavy thump, thump, thump of 50 caliber machine guns firing at a steady rhythm. The gunners aimed at the advancing tanks, some not entirely believing their weapons would be effective against armor. What happened next shocked both sides. The 50 caliber armor-piercing projectiles did not just dent the tanks. They did not ricochet off at angles. They penetrated cleanly and decisively. At close range, some projectiles passed completely through the thin armor, entering one side of the tank and exiting the other. Even at longer ranges, the projectiles punched through the armor with energy to spare. Inside the Japanese tanks, the crews experienced something much worse than defeat. They experienced a revelation. Heavy machine gun fire was not just noisy impacts on the hull exterior. It was penetration. Projectiles entering through the armor. In the cramped interior of a Hago, there was nowhere to hide. A projectile that penetrated the hull could strike engine components, ammunition racks, or crew members. The hardened armor designed to resist rifle fire offered no significant protection against the heavy 50 caliber rounds. A Marine gunner firing his weapon from a position near the airfield reported observing his tracer rounds hit a Hago advancing directly toward him. The rounds struck the front hull, and he could see sparks inside the tank, through the vision slits and hatches. The tank kept coming for a moment, then slowed and stopped. Engine smoke poured from the rear deck. The crew attempted to abandon the vehicle. Two men emerged. They were immediately engaged by rifle fire from Marines in foxholes. Another gunner positioned with his gun mounted on a half-track engaged a Hago at approximately 150 meters. He fired a sustained burst into the tank's side armor. The tank turned toward him, exposing more of its flank. He kept firing. His loader fed another belt of ammunition into the gun. He, Parity, observed the commander in the turret slump forward, and then fall. The bullet passed through the thin turret armor, hit the man, and continued out the other side. The commander never knew what hit him. A third Marine, operating a 50 caliber from a fixed position on the defensive line, engaged multiple tanks as they advanced. He shot into the engine compartment of a Hago, aiming at the rear deck where the ventilation louvers were located. His projectiles penetrated the thin 6mm armor, covering the engine. The diesel engine, its cylinders torn open by 50 caliber impacts, seized. The tank stopped moving, becoming a stationary target. The crew abandoned it, running back toward Japanese lines under a hail of small arms fire. Japanese tank crews who survived the initial assault could not process what was happening. They had trained for years. They had fought in China, where enemy weapons bounced harmlessly off their armor. They had faced Soviet anti-tank rifles at Khalkhin Gol and survived. Their tanks were supposed to protect them. This was the fundamental premise of armored warfare. Tank armor kept the crew alive while they engaged the enemy with superior firepower. But American machine guns were defeating their armor. Not anti-tank guns firing large-caliber shells, not artillery, not even the massive 75mm cannons on the Sherman tanks they could see moving into position. Machine guns, infantry support weapons, weapons that were mounted on jeeps, on half-tracks, on every vehicle in the American arsenal. The realization was devastating. If machine guns could penetrate their tanks, what chance did they have? A Japanese tank officer, later captured after his tank was disabled, told American interrogators that his first thought was that the Americans must have developed some new secret weapon, some advanced ammunition or special cannon that looked like a standard machine gun but fired exotic projectiles. He simply could not accept that a conventional heavy machine gun could defeat a tank. In all his combat experience, from training in Manchuria to fighting in China, small arms fire had always been ineffective against armor. Bullets made noise on the outside. They did not enter. But the Browning M2 was in an entirely different category from anything the Japanese had encountered previously. With its armor-piercing rounds, it had enough energy and penetration power to defeat 12mm armor. At any distance, a machine gunner could accurately engage a target. And the Marines had these weapons everywhere. They were standard equipment in every branch of the American military. As the Japanese tank attack faltered under this unexpected fire, the Sherman tanks moved forward to engage. The contrast was stark. Where the Hago weighed 7.4 tons, the M4A2 Sherman, the variant used by the Marines on Saipan, weighed 31.8 tons. Where the Hago had 12mm of armor, the Sherman had 51mm on the front hull, angled at 56 degrees to provide effective protection equivalent to approximately 75mm against anti-tank fire. The Sherman mounted a 75mm cannon as its primary armament. This gun could penetrate the Hago's armor from over a mile away. When the Shermans opened fire on the Japanese tanks, the outcome was already determined. 75mm armor-piercing shells struck Hagos and Chihas with devastating effect. Tanks were blown apart. Turrets were blown off hulls. Ammunition detonated inside crew compartments. Japanese tanks that returned fire found their 37mm and 57mm shells completely ineffective against the Sherman's frontal armor. The shells ricocheted or created small dents without penetrating. One Japanese tank commander, whose Hago was disabled by .50 caliber fire, but whose turret could still rotate, attempted to engage a Sherman at close range. He ordered his gunner to fire. The 37mm cannon fired its armor-piercing round. The shell struck the Sherman's turret face. There was a flash of impact. The Sherman did not even slow down. It continued to rotate its turret with mechanical precision, took aim, and fired a single 75mm shell. The Hago exploded. The battle devolved into what a Marine officer later described as a madhouse of noise, tracers, and flashing lights. Disabled tanks burned, illuminating other tanks that still attempted to advance. The infantry that was riding on the tanks dispersed, seeking cover in bomb, craters, and drainage ditches. Some Japanese infantrymen reached the Marine lines, engaging in desperate close-quarters battles inside and around the American positions. The Marine infantry, hunkered down in their foxholes, saw Japanese tanks pass directly over them. One Marine later reported that an oil-leaking Hago soaked him heavily as it passed over his position. He remained motionless until the tank moved on, then emerged and tossed a thermite grenade into the engine compartment as the vehicle drove away. The tank began to burn from the inside. Another Marine, hiding in his foxhole as a tank rolled over him, jumped up after it passed and jammed a coconut log into the road wheels. The tank spun in place, tracks throwing up dirt, unable to move forward. When the confused tank commander opened the turret hatch to see what was wrong, the Marine leaped onto the tank and dropped a thermite grenade inside the open turret. The tank exploded due to internal fires, detonating all the ammunition. By mid-morning on June 17th, the Japanese counterattack was over. 31 destroyed Japanese tanks lay scattered across the battlefield, counted by Marines walking through the area after the fighting ended. Some sources suggest that up to 35 tanks were destroyed, including those hit by artillery fire beyond the immediate battle area. Perhaps 1,000 Japanese soldiers were dead, including many of the tank crews and the infantry that had advanced with them. For the Marines, the victory was significant but somber. They had stopped a major armored assault, but the cost had been substantial. The commander of the 2nd Marine Division later admitted that if the Japanese attack had succeeded, it would have been fatal to the division's combat efficiency. The battle had been close, decided as much by American firepower and Japanese tactical errors as by overwhelming superiority. But for the Marines who walked among the destroyed tanks afterward, examining the vehicles up close, a different truth emerged. The Japanese tanks were not the formidable war machines they had expected. A Marine officer called his men over to look at a destroyed Heigo. He pointed to the holes in the armor. They were clean, round penetrations where .50 caliber bullets had punched through. The exit holes on the opposite side were slightly larger, with jagged edges where the bullets tore the metal after crossing the interior. It was possible to fit a fist through some of the holes. Inside the destroyed tank, the scene was worse. The cramped interior showed signs of multiple penetrations. The commander's position in the turret had no protective features, no armor that would stop heavy machine gun fire. The manual turret traverse consisted of a simple crank. The gun controls were rudimentary. There was almost no room to move. The hull machine gunner's position was a tiny cubicle with minimal visibility. The driver had a crude periscope and a small vision slit. Everything was cramped, rudimentary by American standards, and totally vulnerable to .50 caliber fire. Marines who had fought on Guadalcanal 2 years earlier remembered seeing Heigos there. At the time, with the Marines equipped primarily with light weapons and no armored support of their own, the Japanese tanks seemed threatening. But now, with proper equipment, with heavy weapons and their own armor, the Hago looked exactly like what it was. A mid-1930s light tank, suited for its original design parameters, but totally inadequate for modern industrial warfare against a peer adversary. The psychological impact on the surviving Japanese crews was profound. Those who were captured, whose disabled tanks left them no choice but surrender, had to deal with uncomfortable truths. Their tanks were not just outclassed, they were obsolete. The equipment they trusted with their lives offered no protection against weapons the Americans used as standard infantry support. Intelligence officers interviewing prisoners noted a consistent pattern in their responses. The Japanese tankers expressed shock at American firepower. They spoke about the quantity and quality of American equipment. They mentioned the casual abundance of ammunition and supplies they witnessed. Many expressed feelings of betrayal that their own leaders had sent them into battle with inadequate equipment, while telling them they possessed technological parity. A veteran tank commander, who had been fighting in China since 1937, told interrogators that he believed Japan would win the war through superior fighting spirit and devotion to the emperor. After Saipan, after seeing his tank penetrated by machine gun fire and observing the American Sherman ignore Japanese anti-tank fire, he knew that spirit could not overcome material disadvantages. Training and courage meant nothing when your equipment was fundamentally inadequate. These reports were compiled, analyzed, and sent to commanders throughout the Pacific. The lessons learned at Saipan would inform Marine tactics for the rest of the war. Japanese tanks were not a serious threat. Standard heavy infantry weapons, particularly the 50 caliber machine gun, were effective against them. Combined with bazookas, 37mm anti-tank guns, and Sherman tanks, the Marines had overwhelming firepower against Japanese armor. Word spread quickly through the Marine ranks. You didn't need specialized anti-tank weapons to deal with a Japanese tank. Your 50 caliber machine gun would do the job. This knowledge changed how Marines approached subsequent island battles. The fear that came with facing armor, the worry about tanks breaking through infantry lines, evaporated. Japanese armor became just another target, and not a particularly dangerous one. The Battle of Saipan continued for weeks after the failed tank attack. Marines and Army troops fought across the island against fierce Japanese resistance. The terrain was brutal, ranging from flat sugar cane fields to swamps, volcanic cliffs, and Mount Taposho, which rose 1,954 feet above sea level. Fighting in caves, ravines, and gullies consumed men and ammunition. The island was declared secure on July 9, 1944. The victory at Saipan had strategic consequences that went far beyond the island. With the Marianas in American hands, B-29 bombers could reach Tokyo. The psychological impact on the Japanese leadership was severe. Emperor Hirohito recognized that American control of Saipan meant Tokyo would be bombed. Prime Minister Hideki Tojo resigned on July 18th. For the first time, Japanese media admitted the war was going poorly. The loss shook Japan's confidence in final victory. For Japanese tank crews across the Pacific, Saipan was a turning point. News of the battle spread through military channels. Tank units on other islands heard what had happened. They knew their equipment was inadequate. They knew American weapons could penetrate their armor, but there was nothing they could do about it. The tanks they had were the only ones Japan could provide. Japan's industrial capacity simply could not produce modern tanks in significant numbers. The nation's factories were strained by years of war. Resources were limited, with American submarines cutting off access to raw materials from Southeast Asia. Strategic priorities focused on producing aircraft for kamikaze attacks and coastal defense artillery for the anticipated invasion of the home islands. Tanks were a low priority. Japanese engineers had designed better tanks. The Type 3 Chinu mounting a 75mm gun. The Type 4 Chito with even heavier armament. But these existed primarily as prototypes and small production runs. Only 166 Chinus were built during the entire war. 2 Chitus neither saw combat. They were kept for the defense of Japan itself. They were never sent to the island battlefields where they might have made a difference. Meanwhile, American production capacity was almost incomprehensible by Japanese standards. The Detroit Tank Arsenal, built by the Chrysler Corporation, was a facility built specifically for tank production. In December 1942 alone, the arsenal's 5,000 workers produced 907 Sherman tanks. That was more tanks in a single month than Japan produced in an entire year. The arsenal was not alone in this remarkable production achievement. The Fisher Tank Arsenal, built in Grand Blanc, Michigan, was another government-funded facility operated by the Fisher Body Division of General Motors. Fisher produced over 11,000 Shermans in multiple variants, becoming one of the highest volume producers. Like the Detroit Arsenal, Fisher could produce hundreds of tanks per month when operating at full capacity. the American Locomotive Company in Schenectady, New York, converted its locomotive production to build 2,300 Sherman tanks. The Baldwin Locomotive Works in Philadelphia produced over 1,200 tanks while maintaining locomotive production for the war effort. The Lima Locomotive Works in Ohio built the first production M4A1 Sherman, a tank named Michael that was sent to England and still resides in the Bovington Tank Museum. Lima produced 1,655 tanks before returning to full-time locomotive production. Pacific Car and Foundry in Washington State, the Pressed Steel Car Company in Pennsylvania, Pullman Standard Manufacturing in Illinois, and Federal Machine and Welder in Ohio all contributed to Sherman production. 10 major manufacturers, plus countless subcontractors producing components, tracks, engines, radios, optics, and weapons. The industrial mobilization was unprecedented in human history. The Detroit Arsenal itself was a marvel of modern production engineering. Built on 567 acres in Warren, Michigan, the facility covered over 1.5 million square feet of production space. Assembly lines snaked through the building for miles. Massive overhead cranes could lift complete tank hulls and move them between workstations. The factory operated in 3 shifts, 24 hours a day, 7 days a week. The workers included men who had been auto workers before the war, bringing their manufacturing experience to tank production. But they also included thousands of women, many of whom had never worked in heavy industry before. These women, often called Rosie the Riveter, welded armor plate, assembled turrets, installed engines, and performed every function in the factory except the heaviest lifting tasks. They proved that the nation's industrial capacity could be multiplied by utilizing a workforce that had been largely excluded from heavy manufacturing in peacetime. When production ended in June 1945, American factories had built 49,234 Sherman tanks. Japan produced approximately 2,300 Heigos during the entire course of the war, from 1936 to 1943, when production ceased. The ratio was over 20-1. But even this understates the disparity, because American tanks were individually far more capable than their Japanese counterparts. Sherman tanks weighed 30 to 35 tons, depending on the variant. They had armor ranging from 51 millimeters on the hull front to 76 millimeters on the turret mantlet. They carried 5-man crews with dedicated positions for each role. They possessed gyro-stabilized guns that allowed for firing on the move. They had radio equipment in every tank, allowing for coordinated operations. They were reliable with tracks that lasted 2,500 miles compared to 500 miles for German tanks and perhaps 1,000 miles for Japanese tanks. The Sherman was not the best tank of World War II. It was outgunned by German Tigers and Panthers, but it was good enough, and it was available in overwhelming numbers. In the Pacific Theater, where it faced Japanese tanks designed in the mid-1930s, the Sherman was more than adequate. It was overwhelmingly superior. For Japanese crews on subsequent islands, the pattern set at Saipan repeated itself on Tinian. In July 1944, 7 Type 95s were destroyed in counterattacks against Marine positions. On Peleliu, in September 1944, Japanese tanks were buried in caves and used as stationary pillboxes, recognizing they had no chance in mobile warfare. On Iwo Jima, in February 1945, Colonel Takechi Nishi's 26th Tank Regiment buried their tanks in volcanic ash up to the turrets, using them as armored bunkers because the tanks offered more protection stationary than in motion. Even used as static defensive positions, the tanks were vulnerable. 50 caliber machine guns could still penetrate turret armor. Flamethrower tanks could direct napalm into open hatches and vision slits, cooking the crews alive inside their steel coffins. Bazookas could penetrate the thin armor from any angle. The Hago, once a symbol of Japanese armored power, had become a death trap for its crews. On Okinawa, the last major battle of the Pacific War, the Japanese committed the 27th Tank Regiment to the defense. The regiment had 13 Type 95 Heigos and 14 Type 97 Chiha medium tanks, totaling 27 tanks. The Americans landed with over 800 tanks. The i.e. numerical disparity was 30-1. The qualitative disparity was even greater. On May 4th and 5, 1945, the Japanese launched a major counteroffensive designed to drive the Americans off the island. Tank units were assigned to support the infantry assault. The attack failed catastrophically. Most of the Japanese tanks were destroyed within hours, knocked out by a combination of Sherman tanks, bazookas, 37mm anti-tank guns, artillery, and 50-caliber machine guns. The survivors retreated, having achieved nothing except adding more destroyed hulls to the battlefield. In August 1945, when the Soviet Union declared war on Japan and invaded Manchuria, Japanese tank units in northern China faced another technologically superior opponent. Soviet T-34 medium tanks, with their sloped armor and powerful 76mm guns, vastly outclassed the Japanese tanks opposing them. In the Battle of Shumshu Island, part of the Kuril chain, Japanese tanks attempted to defend against Soviet amphibious landings. The Japanese had a mixed force of approximately 77 tanks on Shumshu, including Type 97s and some new Type 1 medium tanks, with only 25 Type 95s. The Soviets used 45mm anti-tank guns, anti-tank rifles, and anti-tank grenades with devastating effect. The Japanese lost 21 tanks in approximately 2 hours of combat. Soviet forces, experienced in armored warfare after years of fighting on the Eastern Front in Europe, quickly defeated the Japanese defenders. The experience of Japanese tank crews during World War II, particularly in the final years, was one of gradual and overwhelming realization. What they believed about their equipment, about their chances, and about their ability to compete with Allied armor was fundamentally wrong. And the moment of truth for many came not in some epic duel between armored champions, but in the terrible simplicity of watching machine gun bullets punch through the armor that was supposed to protect them. For the Marines, who fought on Saipan and the subsequent islands, the lessons were different, but equally profound. They learned that Japanese tanks were not a serious threat. They learned that proper equipment and overwhelming firepower made all the difference. They learned that their 50-caliber machine guns, which they trained with and maintained throughout their service, were actually effective anti-tank weapons in the Pacific theater when engaging thin-armored Japanese vehicles. There was no glory in these lopsided battles. Marines didn't feel heroic shooting at tanks with machine guns and watching them burn. They felt a mixture of relief, pity, and grim satisfaction. Relief that they didn't have to face serious armored opposition of the kind their counterparts in Europe dealt with daily against German tanks. Pity for the men in those Japanese tanks who had been sent to die in equipment that offered them no real protection. Satisfaction because their weapons worked, because American industry had given them the tools they needed to do their job. After the war ended, some surviving Heigo tanks were sent to the United States for detailed examination at the Aberdeen Proving Ground in Maryland. American engineers and armor specialists studied them carefully for months. They measured the armor thickness at multiple points on the hull and turret, documenting the variations. Frontal hull 12 millimeters, hull side 12 millimeters, hull rear 10 to 12 millimeters, turret front 12 millimeters, turret sides 12 millimeters, roof plates 9 millimeters, belly armor 6 millimeters. They tested the steel quality using metallurgical analysis. The armor was face-hardened, a process that made the outer surface harder than the inner core. This technique was effective against small arms fire, causing bullets to shatter rather than penetrate. But it was ineffective against larger projectiles with enough energy to break through the hard outer layer and penetrate the softer interior. They evaluated the internal layout, taking detailed measurements and photographs. The fighting compartment offered only 50 cubic feet of space for the commander. He had to stand constantly, with no seat or resting position. The turret ring diameter was only 1/200 millimeters, leaving minimal room for a man to work, while also operating weapons, loading ammunition, and commanding the tank. The crew positions were cramped to the point of claustrophobia. The driver had a space approximately 2 feet wide and 3 feet deep. His controls were simple, consisting of steering levers, a throttle, and a gear shift. His vision came from a small armored periscope and a direct vision slit that could be opened in non-combat situations. The hull machine gunner next to him had even less room, confined to a small cubicle with his weapon and limited ammunition storage. American tankers who examined the Hagos could not imagine fighting in such conditions. Sherman crews, by comparison, had a fighting compartment that offered over 150 cubic feet of workspace. Each crew member had a defined position with proper seating. The commander had a cupola with all-around vision blocks. The gunner had a telescopic sight and power traverse for the turret. The loader had room to move and access to properly organized ammunition racks. The driver and assistant driver, called the bow gunner in American nomenclature, had adequate space and vision equipment. Their reports confirmed what had been learned in combat and what the math predicted. The Hago was a light tank suited for operations against poorly equipped opponents. It could function effectively in colonial wars, in police actions, and in suppressing resistance where the enemy had no serious anti-tank capability. It was not suited for modern industrial warfare against a peer adversary with proper weapons. Any firearm more powerful than a rifle could defeat its armor. 50 caliber armor-piercing rounds did not just penetrate. They overmatched the armor completely, punching through with energy to spare. The internal arrangement was cramped to the point of being actively dangerous even without enemy fire. The commander's workload, handling all turret functions alone, was unrealistic. The lack of radio equipment in 3 out of 4 tanks made coordinated operations nearly impossible. The manual turret traverse was exhausting and slow. The vision equipment was rudimentary, leaving the crew virtually blind to what was happening around them. Every aspect of the design reflected the constraints Japan faced: limited industrial capacity, resource shortages, and a design philosophy rooted in experiences against inferior opponents. The comparison with American tanks revealed the full extent of the differences in design philosophy. Where the Hago was cramped, the Sherman was relatively spacious, with enough room for crew members to move, change positions if necessary, and work effectively even during prolonged combat operations. Where the Hago had thin armor vulnerable to machine gun fire at close range, the Sherman resisted dedicated anti-tank guns at combat distances. Its 51mm frontal armor, sloped at 56 degrees, provided effective protection equivalent to approximately 75mm against anti-tank rounds. Where the Hago had a single-person turret crew performing multiple simultaneous tasks, the Sherman had 3 men in the turret. The commander could focus on commanding, using his cupola with 6 vision blocks, to maintain situational awareness and direct the crew. The gunner focused exclusively on aiming and firing the main weapon, using a telescopic sight with magnification and a power traverse system that could rotate the turret quickly and smoothly. The loader focused on maintaining a high rate of fire, pulling rounds from organized racks and loading them efficiently. The Sherman's 75mm gun had a muzzle velocity of approximately 2,400 feet per second with standard ammunition, providing effective armor penetration against most targets it would face in the Pacific. The weapon was stabilized in the vertical axis, allowing for reasonably accurate fire even while the tank was in motion, a capability the Hago completely lacked. The Sherman carried 97 75mm rounds in protected racks, compared to the Hago's 130 37mm rounds stored loosely throughout the fighting compartment. Communication capabilities differed dramatically. Every Sherman had a radio, typically an EID SCR-528 or SCR-538 set, allowing for tank-to-tank communication and coordination with infantry and artillery. The Hago had radios in only 1 out of 4 tanks, leaving the other 3 to follow visual signals, a system that failed quickly in combat when smoke, terrain, and enemy action made visual contact impossible. Vision equipment on the Sherman included periscopes with replaceable prisms, direct vision slits with armored covers, and a commander's cupola that allowed for all-around observation. The Hago had crude periscopes and small vision slits that provided minimal situational awareness, forcing commanders to expose themselves by opening hatches to see what was happening around them. Every aspect of the design, from ammunition storage to crew comfort, fire control equipment, and communication systems, was superior in the American tank. But the most telling difference was not in the individual tanks. It was in the numbers and the industrial systems that produced them. The United States had built an economy that could wage industrial war on a global scale. Factories that produced automobiles now produced tanks at rates that would have seemed impossible in peacetime. The Detroit arsenal alone, in its peak production month, produced more tanks than Japan produced in a typical year. Women who had never worked in heavy industry welded tank hulls and assembled turrets. Engineers constantly improved designs, incorporating lessons learned in combat. The supply chain delivered raw materials to factories and finished tanks to ports with clockwork efficiency. Merchant ships transported Shermans across both oceans to battlefields in Europe and Asia. Field maintenance units kept the tanks operational, cannibalizing damaged vehicles for spare parts, and returning repaired tanks to combat in a matter of days. Japan had never built this kind of industrial system. Its economy had been strained by years of war in China, even before the Pacific War began. Its factories lacked the automation and mass production efficiency of American plants. Its access to raw materials, particularly after American submarines began sinking merchant ships, was increasingly restricted. The nation that had challenged the world's greatest industrial power was discovering the true cost of that challenge with every new battle. For the Japanese tank crews on Saipan that June dawn in 1944, and for every Japanese tanker who fought in the Pacific afterward, the lesson was brutal and clear. They were obsolete. Their equipment was obsolete. Their tactics developed for a different kind of war against different opponents were obsolete. And there was nothing they could do about it except continue fighting with what they had, knowing that survival was unlikely and victory impossible. The Marines on the other side learned different but equally important lessons. They learned that industrial power matters in modern war, that having better equipment in greater quantities makes a massive difference, that courage, training, and fighting spirit, while important, cannot overcome fundamental material disadvantages, that the factories in Detroit, Pittsburgh, Cleveland, and dozens of other industrial cities were as important to victory as anything that happened on the battlefield. They also learned something specific and immediately practical. When you encounter a Japanese Hago tank, you don't need to call for anti-tank support, airstrikes, or artillery, although all of those are available if needed. You can engage it yourself with your .50 caliber machine gun. At close range, under 200 yards, the armor-piercing rounds will penetrate. Aim for the engine compartment, the sides, or the turret. The bullets will go through, disabling the tank and likely killing or wounding the crew. The weapon that was designed to shoot down aircraft and destroy light vehicles works perfectly well against Japanese armor. It was a small tactical lesson in a massive war. But, for the men involved, for the Japanese tankers who died in their inadequate machines, and for the Marines who destroyed them with heavy weapons, it was a moment of absolute clarity. That was not a fair fight. It was not a balanced contest. It was a modern industrial war where one side had overwhelming material superiority. The outcome was never in doubt. The Hago tanks on Saipan and every other Pacific battlefield represented more than just obsolete armor. They represented the gap between what Japan needed and what Japan could produce. They represented the impossible situation Japanese soldiers faced, ordered to fight a superpower with equipment that was never designed for that kind of war. They represented the consequences of strategic decisions made years earlier, prioritizing naval and air power over ground forces, assuming fighting spirit could compensate for material inferiority, believing initial victories indicated long-term viability. When those first 50 caliber rounds punched through the Hago's armor on Saipan, they proved something that would echo through the rest of the Pacific War and in the post-war analysis of why Japan lost. They proved that in industrial war between modern nations, production capacity matters, design philosophy matters, and resource allocation matters. No amount of courage, training, or tactical skill can overcome a 10-to-1 numerical disadvantage combined with generational gaps in equipment quality. The Japanese crews who climbed into their Hagos that June morning in 1944 believed they were going into battle with reliable and capable machines. When the sun set on June 17th, those who survived knew the truth. They had been sent to fight with armor so thin that machine gun bullets passed right through it. They had been given equipment that was suited for the war Japan planned to fight in the 1930s, but totally inadequate for the war Japan found itself fighting in the 1940s. And there was nothing they could do about it except continue to serve, continue to fight, and continue to die in machines that could not protect them.